Hey, it's Christian with the Screencast assignment for Chapter 1, Part 1, where we were asked to determine which object, either a cylinder, a sphere, a shell, a rod, which one of those objects would roll off a ramp and cover the most distance onto a table once it reached the end of the ramp. So I approached this first by using the conservation of energy, which is here the kinetic initial plus potential initial equals the kinetic final plus the potential final. So then I went ahead and used that, and then I knew that there is no kinetic initial because it's not in motion yet, and then there's no potential final because it's at the bottom of the ramp and it's only moving at that point. So you can say that the potential initial equals the kinetic final. And then here you just substitute the values for each, and you just get that mgh equals 1/2 mv squared times 1 plus 1 over mr squared. And then I rearranged this whole formula to solve for the velocity because I figured that the object with the highest velocity at the end would cover the most distance. So then I solved and I got this formula. And then I knew that a big number would basically give you the greatest velocity, and that would mean that there would have to be a small number here in the denominator. So there would have to be a really big moment of inertia. Well, the greatest one. So I think that a cylindrical shell would roll off the ramp the fastest and cover the most distance. And then we were also asked to determine what would increasing the mass or radius affect the object, and if you increase the mass or the radius, you're going to decrease its final velocity, and that means that it would roll off the table at a slower rate, and so friction would be able to take over right away and slow it down much quicker. Therefore, it wouldn't cover as much distance.